Hey everyone, in previous lecture I already discussed basic structures of ER diagram and mapping cardinality where I discussed one-to-one, one-to-many, many-to-one and many-to-many. Today I will discuss participation constraint. There are two types of participation constraint. One is total participation, another is partial participation. We can also write minimum and maximum range in the line that connect a relationship with the entity sets. So the minimum and maximum cardinality that we can show as L and H. L for minimum, that is low, and H for maximum, that is the highest. We can write L and H here. L is for lower limit, H for higher limit. And if L equals to 1, means it's a total participation. Every entity of this entity set are participating in the relationship. If maximum value 1 means at most 1. There may be 0 or 1 participation in the relationship, and maximum value star means no limit. It's unlimited. For example, consider the relationship advisor with student. Minimum and maximum cardinality are both 1, and each student must have exactly 1 advisor. So each student can be advised by exactly 1 advisor. That's why it is 1 and 1, and it's a total participation. Every student should be advised by some advisor. So minimum is 1, maximum is 1. 0 star means so 1 instructor may advise to 0 student or more student. So this is the diagram here. 0 star, here is 1 to 1. So student advisor relation, this is a total participation as it is 1 to 1, and this relationship is 1 to many as here it is 0 star. So 1 instructor may advise 0 student or more student. So this is a 1 to many relationship from instructor to student, and advisor student, that is a total participation, whereas instructor advisor, that is a partial participation. As here minimum is 0, some instructor may not participate, may not advise, right? And this is a 1 to many relationship from instructor to student. Thus we can say the relationship advisor from instructor to student is 1 to many, and the participation is total of student in advisor relationship. Okay, that means every student must have a advisor, and if both ages have maximum value 1, then the relationship can be 1 to 1. But here in both ages maximum value is not 1, as here 0 star, that's why it is a 1 to many relationship. If in both maximum value is 1, then we can say it is a 1 to 1. So this is all about participation. We can represent minimum and maximum value in the participation. For total participation, we use a double line. For partial participation, single line. And for total, we can use maximum limit as 1. Next we will discuss complex attribute. I already discussed different type of attributes like simple attribute, composite attribute, multi-valued attribute, derived attribute. Just go through the lecture. Now I will discuss how can represent this attribute in ER diagram. Here is the entity name, that is instructor, and these are the attribute. So ID is underlined, this is the primary key. Then name is a composite attribute. It have different part, first name, middle name, last name. So you can write like this. Okay, next is the street. Okay, street is also a composite attribute. It have street number, street name, apartment number. Next phone number. Phone number is a multi-valued attribute. Okay, one person can have multiple phone number, so that we can write inside the bracket. Next age. Age is a derived attribute. Age value can be derived from date of birth. For derived attribute we use this bracket, and for multi-valued attribute we use left braces and right braces, and for composite attribute we can write the composite part below of that attribute. So this is an entity set with composite, multi-value and derived attribute. Next is role. Role we can indicate in the line. So there is an entity set, there are some relationship. So here we can write the role. Okay, how this entity set is related with this relationship, that we can represent in role. In the ER diagram, by labeling the line that connect diamond to rectangle, diamond is for relationship, rectangle is for the entity set. This is an example. Here course ID and pre-request ID both are role. Next is non-binary relationship set. Till now we discussed just binary set. Binary set means two entity set are related with a relationship. We can also represent non-binary, means we can represent more entity set which are related with a relationship. For example, this is a ternary relationship. There are three entity set: instructor, student and project, which are related with project guide. In such way, we can represent 4, 5, 6. Even that ternary relationship we can convert to binary relationship. We can add some relationship between project and student. Then we can add some relationship between instructor and student. And we can remove this project guide. So in this way, we can convert this ternary relationship into binary relationship. So every relationship are with two entity set. In today's lecture, I discussed participation constraint like total participation, partial participation. Total we can represent by a double line, partial by single line. We can also add lower and higher limit as L and H. Higher limit 1 means maximum 1, at most 1. Okay. Lower limit is 1 means it's a total participation. If every entity are participating, then it is a total participation. If some entity are participating, then it's a partial participation. Next, I discussed complex attribute. I discussed composite, multi-valued and derived attribute representation in entity set, then role and non-binary relationship. We can convert non-binary relationship set into binary relationship set by adding more relationship between each entity set. I already discussed basics about what is strong entity set, what is weak entity set. In next lecture, I will discuss how we can represent in ER diagram, and we will discuss details about weak entity set. If this lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.